Hello, ladies and gentlemen. Root Beer here, looking at question 4 on the 2015 MMC paper. That is the grade 12 level Manitoba math contest. So, for A, find with justification all pairs of real numbers A and B, such that a squared plus 2ab plus b squared, well, that's just a plus b all squared, equal to 9, and a minus b equal to 5. Alright, so get ourselves some paper here. So 9 is a squared plus 2ab plus b squared, but that's just a plus b all squared. So we have a choice. Either a plus b is 3, or a plus b is negative 3. Now in either case, a minus b is 5. And we can use this information. We add them both up. We get 2a is 2 over here. Add them both up. We'll get 2a is 8. That would be a is 4. Or a is 1. So we have we split it up into two different cases depending on what a plus b is. A minus b is something they gave us in the problem. There's nothing we can do about that. So if a is 4 and a minus b is 5, that would make b negative 1. Alternatively, we need a plus b to be 3. Here we need a plus b to be negative 3. A is 1. B is going to be negative 4. So those are our answers. A and b is either 4 and negative 1, or 1 and negative 4. Okay, only two possibilities, and that's what we should expect. Because at most we had quadratic things, a's squareds, b's squareds. But fairly straightforward, provided we recognize that a squared plus 2ab plus b squared is just a plus b all squared. If you didn't recognize that, then I would have recommended rearranging this linear equation, solving for a, plugging that back in, and you will get quadratic in terms of b. And you can solve that for two different values of b, giving you two different values for a, and it would have all worked out in the end. So, for B, find with justification all pairs of real numbers ab such that a squared minus ab plus b squared equals 0. Now, I really wish there were minus 2ab's, because then we'd have a minus b equals 0, but it doesn't look like we're that lucky there. What can we do here? So, I can't think of any way to factor this. No idea why I wrote a K. It should be a B. So I've got one equation and two unknowns. I'm actually not sure what to expect here. If it was a minus 2, we'd get an infinite number of solutions. A would have to be equal to B, but, Well, what can we do? I suppose one thing we could do is a squared plus b squared is equal to ab. That has to be true. So that tells me ab is positive, or at least not negative. I don't know if that'll help. But really, I can't think of anything to do here. So, Well, let's just treat it as though it were a quadratic in terms of a. So we'd have a squared minus ba plus b squared is equal to 0. So that tells me a is negative b plus or minus square root of b squared minus 4ac all over 2a. Okay. So that's b plus or minus square root of, and we have b squared minus 4b squared. Looks like there are no solutions because we're going to get negative 3b squared here. Well, no, we can get a solution if b is equal to 0. So negative 3b squared is less than 0, b is not equal to 0. So no solutions unless b is equal to 0. So let's assume b is equal to 0. Well, then we'll have a squared minus 0 plus 0 is equal to 0. A squared will be equal to 0, and therefore a is equal to 0. So we only get one solution. AB has to be 0, 0. Okay, that wasn't so bad. Not so bad. This observation up here wasn't exactly necessary. But I just had to treat it. You pick your favorite variable, A or B, treat it as a quadratic, and then it all pops out there. B squared minus 4b. Got to take a look at that discriminant. Okay, so that's, what was that? Question number 4, right? Yeah, question 4. In the next video, we're going to look at question number 5. Until then, have yourself a wonderful day.